Alright, this is section 2.7, where we're trying to solve problems using the trig ratios that involve more than one triangle. So, solving problems require two right triangles to model a situation. So, that's what we're doing today. You're going to have two triangles, and you're going to use it to try to answer the problems. Just some quick definitions again before we start. The angle of elevation, remember that? I'll draw a picture here. Yes, it's always measured from the horizontal going upwards. Okay, so measured from the horizontal going up, or I'll say counterclockwise. Okay, angle of depression, once again, measured from the horizontal, but now going down, right? So then once again, but measured from the horizontal going clockwise or down. Okay, so knowing that, let's try some problems. Here's the first one we can deal with today. Two office towers. They are 40 meters apart. Okay, so this distance here is 40. From the 10th floor of the shorter tower, the angle of elevation to the top of the taller tower is 23. So here I am on the 10th floor. If I look up, to the top of the tower, this angle here is 23 degrees. Now, the angle of depression. So, the angle of depression to the base of the taller tower. So, standing at the same spot, I'm looking downwards now. The angle of depression is actually 30. So, that's this one here in red. That's actually 30 degrees. And the question here says, find the height of the taller tower. So, I want you to find the height of this whole thing. So can you see that we have two triangles? If I were to figure out this piece here, let's call it x, that doesn't give me the whole height, does it? But if I also use the bottom triangle and figure out, let's say, this distance here, which we call y, then I hope you can see that we can find the height, which is just x plus y. So we need to do those two pieces and add them together. And that's how we do this question. So let's go ahead and find x first. The triangle in question, if you want me to draw it out for you, x, 23 degrees, and we also know that the horizontal base is 40. What trigonometric ratio should we use? Tangent, I heard someone say. Good. Because this is the opposite side and this is the adjacent side. So x just equals to 40 times tangent 23. And what does that equal to? Hello, calculator. Come on up. Let's see. You come. Hopefully your calculator is quicker than mine, that appears. But you can do that calculation. Here it comes. So once again, make sure you are in radian mode, not radian mode, degree mode. So mode degree, perfect. 40 times tangent 23, 16.97. Okay, so 16.97 meters. Good. Next, of course, we need to find y. I'll draw the diagram again. You don't always have to draw the diagram out, but sometimes I like just focusing on the one triangle. Makes life a little bit easier sometimes. If you're thinking which ratio, and you said it's tangent again, you are correct, because that's y is the opposite. The adjacent is 40, so 40 times tangent 30, that is our y value. Hello, calculator again. 40 times tangent 30, that's 23.09. And so if I want the actual height of the tower, that would be adding x and y. So the height of the tower is the two things added together. And what would that be then? 16.97 plus 23.09, 40.06. Almost the same as the distance between the two towers. Done. Alright? So this is a sample of what you are going to face today. Right? Making sure you can separate them into two triangles, finding information from those two triangles, and then putting them together. Let's try example number 2. Oh, this time there's two triangles embedded in each other. And I want you to calculate the length of KL. KL is just this part here. Now remember, we need to look at right triangles. And I hope you can see there's a smaller right triangle here. And there is a larger one here. What do you think we need to find from both the small and the large in order for us to find KL? Well, if you call this thing here x, which is the length from JK, that's helpful, and we can find that from the blue triangle. I think we can also figure out this distance, JL. That would be y. That would be from the big green triangle. And then to figure out KL, I guess that's just y subtract x. So once again, let's just find those two things separately, and then we'll subtract this time. So I'll say find x. This time I'll draw the triangle again. The right angle was here. 35 degrees, 20, I want x. So once again, which trig ratio should we use? Tangent in this case. And I think you know the drill now, so I am just going to quickly do it. Similarly, we'll ask you to find y. And once again, I don't want to do this for you because I think you can do this now. So go ahead and try yourself and double check your answer with me, please. Seems I like using tangent quite a bit. .64. And now therefore we've got those two pieces. The length of KL is really just the length of JL minus the length of JK. JL is your y, JK is your x, so I'll take 34.64, subtract 14, and that gives you the answer of the length of KL. There you go. Okay. Example number 2 was very similar to example number 1. Not a problem there. But now let's take a look at number 3. Like, this is a kind of weird diagram. So let's read this together. Anne and Byron, they're 35 meters apart on one side of the stream. So if you think about this here, this is the stream, this is the water, okay? They look across and see that the land on the other side of the stream is much higher. So Anne actually measures a few angles. So this is thinking water. This is kind of like, you know, like a, I don't know, a wall. Okay, a wall. And then up here is where there's land for the walk. So she's measuring a few angles. So I want you to realize that this triangle here is actually flat or on the horizontal plane. Okay? And she measured the angle here to be 36. Yet the other triangle, which I'm going to put in red, this one, oops, or green, I'll say, this triangle is also a right triangle, but I hope you can see this spans actually not on the horizontal, but on the vertical plane. Okay? So think of that as the vertical triangle. So the question is, she wants to calculate the height of the cliff on the other side of the stream, meaning I want you to find h here, this distance here. Now there are two triangles, and they're connected. They're connected by this length here. So I think we need to find that first. Okay? And in order to do that, once again, we're going to separate the two triangles. I'm going to look at the blue triangle first. So I'm going to redraw the blue one for us. And the blue one is once again on the horizontal plane. 35, 36, and I want us to find this side here. So think about what trigonometric ratio should we use to figure out this, which I'll call, I don't know, side S. I've got 36 as my target angle, 35 is the adjacent side, yes, and S is the hypotenuse. So if you said cosine of 36 is equal to adjacent, which is 35 over S, the hypotenuse, I am very happy. So now we'll cross multiply. S times cosine of 36 degrees equals to 35. S then equals to 35 divided by cosine of 36. Calculator time. 35 divided by cos 36. And there you have it, 43.26. Cool. Now, why is that helpful? Because that is the same length as now the, I guess, the base of my green triangle. So now if I were to look at the green triangle and draw that out, I've got the angle of 68. This side here, once again, is exactly the same as the hypotenuse of the blue triangle. And I calculated that as 43.26. And now I should be able to figure out the height of the cliff. So, in this case now, with this diagram, you got it. Tangent is your friend. Once again, tangent. I love tangent, don't I? 43.26 times tangent 68 degrees. Go ahead and calculate that, and then we are done. Well, at least I'm done this question. 107.07. 107.07 meters. That's a pretty high cliff. Don't jump off of that. All right. Okay, if you're set, we can move on to two more, and then I think that's it for not just this lesson, but this chapter. You've learned everything you need to learn for the chapter 2 topic of primary trigonometric ratios. Okay, I think for this one, I'm going to let you try this yourself, perhaps. And then from there, you can come back and double check your answer with me. My advice to you is to start with this triangle. Hopefully you can calculate a length that is shared on both sides, like this one here. And then ultimately, we can use the red triangle to solve for x. Okay, it's your turn. Go. Hey, don't wait for me. Do it yourself first, then come back and double check. If you're thinking, what trig ratio can I use? Well, unfortunately, you can't, because I want to find the third side. Knowing that you have two sides and you want to find the third, you actually have to use Pythagoras. Yes, you can also use stuff from things you learned in the past. If I call that A then, a squared plus 10 squared equals 26 squared. That's 100. 26 is what? 676, I believe. A squared then equals to 576. And I think a just becomes 24. Let me just double check that. Square root of 576. Yes, it is 24. Perfect. Now that means I can look at the red triangle. 32 degrees. Right angle. This is now 24, and now the question is, how do I solve for x? Now you can use trigonometry. Which ratio should I use? Sine, cosine, or tangent? Think SOHCAHTOA. 24 seems to be the opposite side of the target angle. The x is the hypotenuse. Opposite hypotenuse, that's right, sine. Sine 32 equals to the opposite, 24, over the hypotenuse, which is x. Cross multiplying again. Dividing this time by sine 32. And let's see what the calculator says. 24 divided by sine 32. There you go, 45.29. Oops, I want to round to one decimal place, so how about 45.3? Yay! Yay! All right, one more. A rectangle prism. How about a rectangular prism? rectangular. A rectangular prism has a length of 100 and a width of 80 and a height of 50. Okay, so 100, 80, 50. What is the length of the body diagonal? Oh, the body diagonal is this x going from one vertex to the opposite vertex. Wow. So, kind of like that example number 3, the one with the cliff. You see, this x actually is in the vertical plane. So if I were to draw this along with this and connect this side here with y, this is actually a right angle here in the vertical plane. I hope you can see that. If you're looking at another triangle, I can see this one here, this, and this is also a right angle, because this is a right angle in the horizontal plane. So there are my two triangles. So can you figure out x now? Yeah, you got to figure out y first. So we'll find y first. I'm given only two lengths, so once again, to find the third side, it's Pythagoras time. In this case, it's y. 100 squared is what? 10,000. 80 squared is 6,400. So 100 squared plus 80 squared equals 16,400. We're going to take the square root of 16,400, 128.06. $128.06. That's y. But that's not what we want. We want x. So after finding y, now we can go about going and finding x. And in this case, we're going to use the green triangle. And lo and behold, we're going to take the 128.06, which is y. We're going to square that because that's my base. Add to that 50 squared, and that now equals to x squared. Now this number here is actually equal to, if I go backwards, that's the same thing as y squared. So that's just 16,400. And then 50 is just 2,500. So we can add those together to get x squared. Big numbers. That's 18,900. So x just equals to the square root of 18,900, and that's equal to 1 137.47. 137.47. And this is, I believe, in meters. Oh, centimeters. There we go. Okay. So it's not just about using trig ratios, it's about using Pythagoras as well. But here comes part B. What is the measure of the angle between the body diagonal and the diagonal of the base? So if I were to actually ask you to actually calculate this angle here, the one between the body diagonal and the base, that's pretty much the green triangle. Right angle here, 50 here. Asking you for the angle, and I've given you x and y. X is 137.47. Y is 128.06. And so you can use whatever trig ratios you want, because you actually have all three sides. So up to you which one you want to use. You know me, you know which one I like. That's right, it's tangent. So I'm just going to use tangent to do this. You can use sine or cosine, it's up to you. Just make sure you use the right numbers. And then because you're finding the angle, we're going to do the inverse tangent of the ratio. 50, 128.06. Whoa, what did I just press? No. Here we are. Okay. And once again, inverse tangent, shift tan. 50 divided by 128.06. And that gives you 21.3 degrees. Now, you can use other ones too, right? You don't have to use tangent here. You could have used sine. If you use sine theta, it'd be opposite, which is 50 over 137.47. That should also work. If you use cosine, that would be the adjacent side, 128.06, divided by 137.47. And you should be able to get the same measurement of 21.3 degrees. Okay, there you go. That's it. Congratulations on completing all the lessons for Chapter 2. Here's your activities that you can do.